Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. I am so excited to be here with you today. Wednesday nights I always look forward to because we get to hang out together and do some math problems. As Dr. A said, we are here to help you pass your exam. So we are going to be going over math problems tonight. So whatever test you're prepping for, we probably have a math problem ready for you. In the comments, I always like to start with this because it just helps me get to know who's in the room. So in the comments, let me know where you're from, what test are you prepping for, and I always do a get to know you question. So here's a good one. Are you a Jif peanut butter person, or are you a Peter Pan peanut butter kind of person? I feel like there's like a stern line, like people either like Jif or they like Peter Pan. I like Jif personally, but what do you like, Jif or Peter Pan? So where are you from and what test are you prepping for are the more important questions because it helps me guide my rabbit trail conversations tonight as we dive into each problem. Now, I will tell you, in each problem, they're not all, for every grade level, but I do try to extend or bring down so that everybody can benefit from every problem. Hi, Nisi. It is nice to see you. You're from Tallahassee, GK Math, Jif all day. Nice. Hey, Joseph from Connecticut. And you don't like peanut butter? I love peanut butter. Peanut butter and apples, peanut butter toast, peanut butter ice cream. I am a peanut butter girl. Hi, Sheba. You want to teach in Atlanta, but you're from the Bahamas and you have to take a Praxis test, but you're not sure which exams you have to take. That is not something that is my expertise. You would actually probably have to call the Department of Education in Georgia for them to tell you what exams that you would need to take based on what you're looking to do. Hey, Donna, good to see you. Deathly allergic to all peanut products. That's so sad. Hey, Hope, good to see you. Lots of familiar faces tonight. I love it. Now, I'm also going to say that if there's anything that you're struggling with, please let me know in the comments, because I will use it to gear my problem development for next week. So last week I had a lot of requests. So you'll see every problem that has a star next to it. So like this one has a star next to it was a specific request. So someone either sent me a problem like that, or it was a concept that was specifically requested. Nisi, we are definitely going over functions today. So I'm going to add a page in here for our list of concerns, so that we can go over anything that you want me to go over next week. And my notability just failed me. So we're just gonna try that again. This silly app, I don't know why it does that. Okay, so functions is something that we want to see. I'm definitely going over functions today. Probability, I don't have any probability today. Hi, Milagros, it is so good to see you. But we will add probability into next week. All right. As you think of things that you want me to go over next week, let me know. I'm going to get started with our first problem for tonight. Maximus makes $35 for every unscreened pool he cleans and $20 for every screened pool he cleans, and an additional $10 for pressure washing the deck. Maximus is currently servicing 9 clients' pools. He cleans 5 unscreened pools and 4 screened pools and pressure washes 3 of their decks. How many more dollars will Maximus make if he raises the cost of the unscreened pools to $40 and the screened pools to $30 and begins to pressure wash 2 more client decks? All right. So, hey, Hannah, I do have that problem in tonight's set. So we are definitely going over that. So if you are an algebra-minded individual, you are going to immediately think that this is a system of equations. So this problem is actually really good for everybody involved, because at the elementary level, we can create a table of values. At the middle school and high school level, we can create a system of equations. So at the middle school and high school level, we are thinking immediately of systems of equations, right? And at the elementary level, we can just kind of do this by simple arithmetic. So he makes $35 for his unscreened pools, and he makes $20 for his screened pools, and he makes an additional $10 for pressure washing the deck. Now, how many of each of those is he doing? He's doing 9 pools, but that number is kind of like a number they're using to trick us, because we're not really going to use that information. What we are going to use is the 5 unscreened and the 4 screened, and he's pressure washing 3 decks. So what I'm going to do is I'm going to figure out how much money he's making right now. So I'm going to do 35 times 9, the money times the number of pools. And then I'm going to add that to 20 times 4. And then I'm going to add that to 10 times 3. Are you following where I'm going with this? So these are his unscreened pools, his screened pools, and the pressure washing decks that he's doing. So now I can go ahead and figure this out. Now, if you're taking an elementary test, you are not going to get a calculator. If you're taking a GK, you get a 4-function calculator. If you're taking a middle school or high school test, you probably have a calculator in front of you. I am going to go ahead and use a calculator just in the interest of time and accuracy tonight. So I'm going to do 35 times 9, and that's going to give me 315. Plus 20 times 4, 20, 40, 60, 80. Plus 10 times 3, Oh, goodness, 35 times 5. See, I said that 9 is a trick number, and here I am getting tricked by the number 9. Y'all are way too good to me. 35 times 5 because it's 5 unscreened pools. This is why I love when you guys comment, because it just makes it so much easier and more fun because we're all in the same room. So that's 175. Thank you. Sorry, Sheba, I confused you because I was solving the problem incorrectly. Thank you, Joseph. Thank you, Donna. All right, and then 10 times 3 is 30. Now, when I add all of that together, 175 plus 80 plus 30 equals 285. What is that number? That's the number of money that he's making before the prices raise. But then we have our cost increases. So now instead of $35, he's going to charge $40. And now instead of $20, he's going to charge $30. And now instead of 3 decks, he's going to service 5 decks. So now let's solve that. 40 times 5 is 200. Plus 30 times 4 is 120. Plus 10 times 5 is 50. 200 plus 120 plus 50 equals 370. And the question was, how many more dollars? How much more money is he making? Well, he's not making 285 more dollars. He's not making 370 more dollars. We're going to subtract the 370 minus the 285 to figure out that gap of how much more he's making, which is $85. Questions? All right, let's move on to the next problem. Select the equation below that has no solution. All right. So, how am I going to figure out something that has no solution? So, I'm going to solve each of these and at least try to get like an x equals or a y equals or get them to be the same, and you'll see what's going to happen. So if I distribute this 4 all the way through, we're going to go up here. I'm going to get 4x minus 12 plus 2x equals, and I'm going to distribute this as well, 2x minus 12. I see right here, if I do 4x plus 2x, I'm going to get 6x minus 12 equals 2x minus 12. Then I'm going to do minus 2x plus 12 plus 12. 6 minus 2 is 4x equals 0. Divide both sides by 4, x equals 0. Is it possible for x to equal 0? Absolutely. Now let's move on to the next one. So if I simplify this, let's go down here. Negative 1/2 x plus 2 plus 9/2 x equals 8x plus 1/2 minus 4x minus 3. I'm going to distribute this 1/2 through, negative 1/2. So I'm going to get negative 1/2 x Negative 1/2 times 2. All right, this is something that confuses people. When we do multiplication of fractions, I'm going to put my whole number over 1, and I'm going to multiply all the way across. So I'm going to get negative 2 over 2, which just gives me negative 1. Plus 9/2 x equals, distribute, 8x. 8 times 1/2 is 4, because 8 over 1 times 1/2 equals 8 over 2, which equals 4, minus 4x minus 3. 8x minus 4x is 4x. 4 minus 3 is a positive 1. 1/2 x plus 9/2 x. Let's do that over here. 1/2 x plus 9/2 x. And this is a negative. When I have common denominators, I can go ahead and add or subtract. 9 minus 1 is 8x. 8 over 2x, which is 4x. So I have 4x minus 1. Now, when I subtract 4x from both sides, I get negative 1 equals 1. Does negative 1 equal 1? No. So B is going to be our answer. If I look at C and I distribute this, I'm going to end up with 10 plus 3x, which is going to be the same as 10 plus 3x. So we know that that's going to have a solution. And if I look at this one actually has a typo. So this one is going to distribute to be 4x minus 4 minus 3y plus 12. 12 minus 4 is 8. So this is going to end up being 4x minus 3y equals 8. So this should actually be an 8. But you see very clearly that this has no solution because negative 1 does not equal 1 ever. So if we're looking for an equation that has a solution or doesn't have a solution, if we get something that's like 4 equals 7, we know it doesn't have a solution. So let's go ahead and go on to the next problem. Now, I had people request last week and today for functions. So this is a problem that we are looking at for functions for any middle school or high school or like a GK or a Praxis core, because GK and Praxis core are both like 4th through 9th grade math. So the functions of f, g, and h are shown below. F of x equals 2x squared minus 4x plus 9. G of x equals 4x minus 4. H of x equals 5x minus 3. What is the value of f of h of x when x has a value of 3? This kind of problem is often so confusing for people. Not because they don't understand what these mean, but because they don't understand what this means. So let's go ahead and go over the different variations of that you might see. You might see this. What is the value of f of x plus g of x? In that case, you're going to literally add the functions. So you're going to take your f of x function and you're going to add it to your g of x function. And you're going to simplify. Now, if you had f of x minus, and it disconnected, so we're going to reconnect. If you had f of x minus g of x, that's where things get tricky because you need to make sure you distribute that negative all the way through. And that's where people usually make their mistake. So if we have f of x minus g of x, you would still do 2x minus 4x plus 9, but we would be subtracting, but I'm not just going to write minus 4x minus 4. I'm going to write minus this entire unit because we're subtracting the entire unit. Technically, I could also do that here, but the parentheses are really unnecessary. This means I'm going to then distribute that all the way through. All right, let's go to the next one. F of x times g of x. That means I'm going to multiply them. So in that case, I'm going to have instead of a plus sign in the middle, we're just going to write parentheses because we're going to multiply those. But this, that does not mean multiply. And that's what most people assume. This does not equal this. This means, okay, let me go back to this. If I said find f of 3, what would you do? You would plug 3 into the function of f. And I'm actually going to change that since this problem has a 3, f of 2. You would take the f function and plug in 2 anywhere there was an x. So we would do 2 squared minus 4 times 2 plus 9. Because anywhere there's an x, I'm going to plug that 2 in. So with that knowledge, what does that mean I'm going to do here? Anywhere there is an x value, just like I did here, I'm going to plug in h of x. What is h of x? 5x minus 3. So anywhere there's an x, I'm going to take that whole chunk and put it in for the x value. So that's going to look like f of h of x equals 2x squared minus 4x plus 9. Anywhere there's an x, I'm going to put h of x. So 2 times 5x minus 3 squared minus 4 times 5x minus 3 plus 9. Now, am I actually going to figure out what that is? No, because it's going to be a lot more work. They want to know what this is when x is 3. So I need to do f of h of 3. Well, first I need to figure out what is h of 3. Well, great question. H of 3, plug 3 into your h function. Plug 3 in. 5 times 3 minus 3. 5 times 3 is 15. 15 minus 3 equals 12. So h of 3 is 12. Using the substitution property, I'm going to remove this and put a 12 there. So now I'm going to find f of 12. That's a lot easier than trying to FOIL this out, distribute this, and then plug the 3 in. So f of 12 equals 2 times 12. I understand why sometimes my iPad does that. I have yet to figure out like what I do to just randomly make my iPad disconnect like that. So I am going to plug 12 in for my function. So 12 squared minus 4 times 12 plus 9. Now, I can immediately see that the values of this are going to give me much larger numbers than 12 and 15. I know that 12 times 12 is 144. So if I was running out of time at this point, I would be picking one of these values. Let's go ahead and use order of operations. This is for my elementary people, and solve. 2 times 144, because 12 times 12 is 144, minus 4 times 12 is 48. I did all my multiplication first. 2 times 144 is 288, minus 48, minus 9. 288 minus 48 minus 9. Oh, plus 9. Hello. Is 249. So D is the correct answer. Now, I was able to self-correct that error because I saw my answer choices and I said, my answer that I just got is not in my answer choices. Well, the answer choices aren't wrong, especially when you're taking a test. Maybe on Wednesday night math night, we every once in a while have a wrong answer, but not when you're taking your test. So that's a quick way for you to self-check and see where you went wrong. All right, there's functions. Check that off the list. Let's go ahead and go on to question number 4. Someone specifically requested geometry. So let's go ahead and solve this volume problem that is very much an elementary school problem, but we all should know how to solve it. A gardener is creating a topiary. Topiaries are those like bushes that are shaped. So when you go to the Epcot like Flower and Garden Festival, that's all you see at Epcot are those like shaped bushes, like a bush cut out, into the shape of the beast from Beauty and the Beast or whatever. So a gardener is creating a topiary. She starts with a cone and then cuts the top off the cone to create her desired shape. So her desired shape is the one that's down here. What is the volume of her topiary? Using the volume formula for cone, which is 1/3 pi r squared h. So, what is the volume of this topiary? Well, unfortunately, we don't have a volume formula for this like cut off piece of a cone. It kind of looks like the Apollo space capsules, doesn't it? So what we have to do is we see that there's a bigger cone and there's a smaller cone. So I need to do the volume of the big cone minus the volume of the small cone, and that will give me the gray shaded area, right? Now, why do I write this out? It is critical that you are planning for your problems, especially when they are multi-step. It is critical that you are planning for your problems, especially when we're looking at a multi-step problem. So I write this out so that I don't get lost in my work. So how do I find the volume of the big cone? Well, volume equals 1/3 pi r squared h. Now, I'm going to look at my answer choices and see, are my answer choices in terms of pi or are they rounded off? And I immediately see that these are all rounded off, which means that they used a value of 3.14 for pi. Now, elementary people, if you were doing this problem, and this is absolutely a elementary level problem, they likely would not require you to do all of this multiplication, including the 3.14, purely for time's sake. Not because they don't think you can do it, but because it would take up too much time. So in that case, your answers would most likely be in terms of pi. But because it's not, we're going to use a calculator. So I'm going to do 1/3 pi r squared. R of my big cone. Radius is going to be that measurement from the middle of your circle to the outside of your circle. And I just realized I know I don't have a correct answer here because I took this problem from somewhere else and I meant to change it, and I just realized I did not change it. So we're just going to erase the answer choices and move on. So radius is from the middle to the outside. They gave us the entire length here, which is 16. So my radius is only going to be 8 because 8 plus 8 is 16. So 8 squared times h. H is 22. So I'm going to use my handy dandy calculator. 64 times 22. 1/3 times 3.14 times 1,408. Continuing to use my calculator. And now, rather than trying to multiply times 1/3, I'm going to divide by 3. Because multiplying by 1/3 and dividing by 3 are the same thing. And that's going to give me 1,473.70 is the volume of my big cone. Now, what is the volume of my small cone? So let's look at small cone. The small cone is going to be volume equals 1/3 pi r squared h. So volume equals 1/3 pi times r squared times h. What is the r and the h going to be of my small cone? My r is going to be 4. My h is going to be 10. So that said, my r is 4, my h is 10, so I have volume equals 1/3 times 3.14 times 16 times 10. I'm going to punch all that into my calculator. And that's going to give me 167.47. Now all I have to do is subtract 1,473.70 minus 167.47 equals 1,306.23. And that would be the volume of our small cone. Why do you subtract the gray shaded area? I'm actually not subtracting the gray shaded area. I'm subtracting the white part because I had a big cone and then I cut the top off. And so I'm taking the white part off, and that's going to give me the gray part. Awesome job, everybody. All right. I'm going to kind of skip around purely because my computer just told me, alert, alert, your computer is about to fall asleep and it was fully charged. That's because my computer needs to be replaced. So I know what I'm doing this week on spring break is buying a new computer because we need my computer to last for the entire hour we are together. So we're going to get through as many problems as we can before I have to sign off, and it is not going to go until 7 tonight because of that. So I am going to go over a couple of problems that were specifically requested. This one was specifically requested. So a square has side lengths which measure 3 2/5 centimeters. What is the area of the square in square centimeters? So here's the deal. 3 2/5 times 3 2/5 is not the same as 3 times 3 plus 2/5 times 2/5. Fractions are very weird. And so if we take a look at this, in terms of like a FOIL, if I were to split this into an addition problem, this would be 3 plus 2/5. And if I split this into an addition problem, it would also be 3 plus 2/5. But this is a multiplication sign, not an addition sign, which is why we cannot do 3 times 3 and 2/5 times 2/5. Because you and I both know that when I multiply things, 2 binomials together, I have to multiply all 4. Now, that's the long way to solve it, but that's the explanation for why this is not the same as that. So here's what we should do. We should turn these into improper fractions or fractions greater than 1. So 3 and 2/5 turned into a improper fraction is going to be multiply these and add these. So we're going to get 17/5 times 17/5. When I do that and I just multiply straight across, 17 times 17 is 289 divided by 25. If you're taking the GK, 289 divided by 25 in your calculator is 11.56 C. If you're not doing it in the calculator because you don't have a calculator, you can do 289 divided by 25 the long way. And you realize that 25 can only go into 39 one time, and 11 is the only answer choice that is a whole number. So therefore, we really don't need to worry about solving that, like, because I don't need the fractional part of that. All right, let's move on to a quick calculus problem, and then we're going to have to sign off because my computer's about to die. The graph of the function is shown in the preceding xy plane. 5 values, A, B, C, D, and E, are indicated on the x-axis. At how many of the 5 values does the function appear to be continuous, but not differentiable? Okay, here's what I want you to look for first. Points of discontinuity. So if I'm looking for places of discontinuity, I'm looking for holes, I'm looking for jumps, and I'm looking for asymptotes. So this is discontinuous, this is discontinuous, and this is discontinuous because I have a jump, an asymptote, and a hole. So just by looking for where, because we're looking for where the function appears to be continuous. Just by looking for continuity, I've eliminated C and D. So I only have A or B left. Now, I could explain to you all the reasons why, but if you're taking a test that has calculus on it, there's a very limited amount of calculus on any test. It's less than 10% on most exams if there's calculus on it. I would just memorize that anytime it comes to a point like that, it's not differentiable. The end. There is a really long reason why, but let's be honest. We're trying not to shove an inordinate amount of information in our head. If you can just remember at a point like that, it's not differentiable, you'll be golden. Therefore, there's only one spot that is differentiable and continuous, and it's D. All right, 7 points. So close. You've got this. Why not 3 and 4? If you are not taking a high school exam, it's not necessary for me to explain that. However, I will, because there's only 5 points. And at the 3 highlighted points, it's not continuous. So it only leaves me with 2 points left. All right, my friends, I am going to sign off. Next week, I am going to go over another calculus problem, and this problem right here. And then any problems that you want to see, functions and probability will definitely be on the list. If there's anything else you want to see, drop it.